Networking introduction. Networking, what does it mean? Networking. Networking means collection of devices that can help us communicate, not only just communicate, that helps us to share some resources such as printer. See, in your Nokia office, I have seen shared printer. You can print from anywhere and just come and swap your ID card and it prints your document. I've seen that when I was there in Navalu. Um, so the resource, you don't need to buy a dedicated printer for each employee. You just got one big printer in a corner of your floor where everyone can come and take print out, but the print is initiated from their computers. Print, any employee can initiate from the computer, their computer, which can be printed by one single printer for the entire floor. It is all because of networking. So networking is not only just for communication, it is also to share resources such as printer, sometimes scanner, sometimes a hard disk. You know, we used to have a data center. We have lot of disk, array of disk storage, where all the employees' data are put inside one big common storage. That is what we call it as data center. Data center will have a common server pool, storage pool. A lot of resource pool will be there. That is what data center. Now we can access this data center from anywhere in the floor, anywhere from the building, anywhere even from outside the world if it is shared to the outside world. So networking is nothing but collection of devices that helps us to communicate, share resources such as printers, servers, storage, cloud computing. That is also networking. People no need to buy big servers. We need to simply subscribe for a big server by using a small, low profile, Rich Street laptop, 4,000 rupees, 5,000 rupees laptop. You can access a big server from the cloud. What is the cloud? Cloud is again another data center somewhere with a pool of resources, big resource like CPUs and RAM and big motherboard, big computer. So according to your requirement, they slice some portion of resource. They create as a virtual computer. They allow you to access that computer. That's what we call as cloud computing. So this is possible only because of this networking. So networking is the I cannot just limit it as a group of device for communication, sharing of resource. Now networking is all that we see in today's technology. Anywhere you go, you have networking. Say for example, I just came back from West Side. They don't provide bill now. They say, sir, it will come to your WhatsApp message. The bill is not even physically given. They already know my phone number because I have a membership card in Westside. And as soon as I purchase, they say, sir, bill will come to you, your WhatsApp. And as they say, yes, I got the bill in WhatsApp. It is all because of networking. So I cannot limit networking now in 1 or 2 or 3 lines. Networking has become part of our daily life. Even food is because of networking today for some bachelors. They don't cook at home, they just simply order online. And for some, shopping is only networking. Buying medicine also sometimes for some people it is only through networking. Vegetables, so networking has become a part of life now. But as a network engineer, what we need to talk about networking. Networking is the backbone that helps to have all these applications that we were talking about: ordering food, ordering medicine, buying from Amazon. All these applications uses one common backbone, which is networking. Which is networking. In this networking, there are some important components that we should know. Number one is the end device. We call it as host. This end device can be your cell phone. This host can be your laptop or a computer desktop, or even it can be a server, or it can be an iPad, or it can be any gadget that can interact with the remote people, like smartwatch, etc. Siri, there's some series there, and many more Google apps out there, which can talk, which can sense our voice and bring information. So those end devices are called as host. Right now, I'm using a laptop. You may also be using laptop on the other end. That is important for networking. If your laptop and my laptop don't support networking, if they can't talk to that backbone, if they can't talk to that core network, communication is not possible now. We cannot have this class. So it's because your laptop and my laptop supports this communication, can become a part of interconnecting devices. We are able to have this online session. Now, next is the switches. Switches are very important device to connect multiple hosts. Hosts can also be a printer. Hosts can also be a printer in a network, can also be a scanner in a network. Now, when you give a print command, when you print a document from your desktop in your office, desktops are connected through the cables to the backbone network, and the backbone network is also connected to the printer. So when I print from the desktop, I'm able to get the paper printing there in the corner of my bay. It is all because my desktop and the printer, they are connected via a switch through cables. Sorry. So switches are very important. We have like 300 people in a floor. All 300 can access that one big printer, which means there are 301 devices connected to that switch. It may be one switch, it may be a collection of switch, because all 300 may not be accommodated in one switch. Say switches comes in various size. Some switches are just 12 ports. Only 12 devices you can connect. Some switches are 24 port switch. Some are 48 port switch. Some are 96 port switch. I have even seen 300 port switches. So switches are the intermediate device with which many devices can form a group. All the employees forms one group. In that group, we also connect the printer so that all the members of this group can print. Without switch, that is not possible. And everyone should go and physically connect to the printer and then print if we don't have that switch. So switches are important. When we go to the next topic some other day, we will talk in OSI switches as a layer 2 device. Layer 2 device. So what you are learning about switch now is not all, it is just an introduction. We will be learning switching topic itself for many days. There are many topics in switching. So just as an introduction to the network devices, I'm just talking here about switch. So we need a host, we need a switch. We also need routers. Routers are also very important for network. Why? Switches can only help you to group members of same department, same network. For each department, we will have different network. For each department, we will have different network. If members of different network need to communicate, then we need router. Switches can't help. Switches are only layer 2 device, so they cannot help layer 3 routing. Routing is layer 3 of OSI. If you don't know about layer 2, layer 3, just ignore now. You'll be learning in detail later. So we got hosts, switches, routers. Not only this, we also have firewalls. See, these firewalls are protecting device. These firewalls can do the job of router, also job of switches. Along with that, they also have that ability to protect your network. That's why it is called as firewall. This course is not about firewall, that's security track, but I want to tell you this is also part of network. We need to protect the network. In order to protect the network, we have firewalls. You see, the word is very clear, firewall. The wall that protects the city from the fire. The wall that is surrounded, the city that is surrounded by the wall, so that the forest fire in ancient day, which happens very often, the forest fire won't come inside and hurt people. They used to build a wall around the city. The wall will be tall enough to protect the people inside the city from fire. So they copied that idea from there. This is the perimeter device, firewall, means it will be the border, like a compound wall. Anyone who wants to enter into your network, they have to go through this firewall. And when firewalls see that as an abnormal packet, it will stop. It won't allow the abnormal packet to get in. That's why it is called as firewall. It protects from anomalies. It protects from anomaly is the word to say abnormalities, anomalies. Firewall. A firewall protects network from harmful uh, traffic, network traffic entering in. Now, these are the major devices that you currently see in our network. Host means all the end users. We are all end users. Right now, I am one end user talking to my laptop mic, and the mic connects to the motherboard. And the motherboard has got a NIC card, network interface card. What is that? NIC card, network interface card. This is the place where I connect my wire, the internet wire. So through the NIC card, through the wire, the traffic goes to my router. And that router is connected to the internet. And you on the other side, connected to the internet with your router, you may be having a Wi-Fi, and you may have a laptop with Wi-Fi. So I, with this computer, generating the traffic comes to the router, and from the router to the internet, from the internet to your router, from your router to your laptop. You're able to hear my voice now. You're able to see my screen now. Same process happens when you unmute your mic and when you speak to me through the wireless, it comes to the router and the router pushes to the internet and the internet sends the traffic to my router and my router sends the packet to my computer's NIC card, and my computer can process it and I can hear it in my headphone. Now, if I have more than one computer, then I need to buy a switch. I have like 2 computers for my children, so I need a switch. Because as I am talking to you, they're also watching some program, attending abacus class, things like that. So we need a switch. Switches we draw like this rectangle. But routers, we don't draw like this. This is not correct. Routers we draw around. This means router. If you just draw a rectangle, it is switch. So you may have a wireless router. It may physically look like a rectangle box, but this is the symbol that you should use to say router. Yes. So we have these devices. Depending on the size of your company, the number of devices will vary. You may have 500 hosts, 50 switches, 10 routers, 1 or 2 firewalls. Yep. So this is important to know. But there is some device in the market, not in the company, not in the enterprises, not in big company. In markets, they will sell for small houses. Bridge. Bridge is also same like switch, but internal architecture is not same. For low budget, for small network, people will buy bridge instead of switch. Whatever switch will do, bridge can also do. But bridges cannot handle traffic like switches. It cannot handle that big volume of traffic what the switch can handle. So we can say bridges are the smaller version of switch. You see, we need to know the difference between switch and a bridge. Though it is not so important, but people sometimes test like asking the difference between bridge and a switch in interviews. So now let us learn the difference between bridge and a switch. If someone asks the question, difference between bridge and a switch, what exact term they are looking for from us? This is what they want to hear from us. Bridge is a software based device, whereas switch is the hardware based device. Whenever I say this, I laugh myself. The reason is long ago, like 18 years back, I was in one training given by HCL in Greens Road or whatever road in Chennai, Greenways Road or something like that. So the person who was telling the difference bridge and switch, I asked him, hey, you say software based device, what does it really mean? He told a story which is not true, which is not correct. That's why I laugh. See, till today I laugh at it, the answer that he gave me. It's a funny answer. Though the time I thought it is the right answer, I got convinced when he was telling that story. But later I realized that it is not true answer, it is a story made by him. Bridge is a software-based device. You know why? Because it's a software. Because it's a software, you can install in a laptop, and laptop will start working like a bridge. I was confused. How can laptop help communicate 10 computers? See, if I want to connect this 4 computer, how can one laptop installed with that software sitting here help to communicate? Then he told one another lie. Because he don't know the answer, he was making this story. In the laptop you will have many ports. And then you can connect one port here, one port here, one port here, funny stories. And then install the software in that laptop. And the laptop will become an intermediate device for these devices to communicate. So instead of that, he could have Googled and told me some better answer. This is not correct. You see, both switch and you have some question? Okay. Both switches and routers, both switches and bridges will look like this only. Appearance wise, both will have Oh no. Both will have some ports. And right, to see physically it is a rectangle box, metal box. Both have got some good number of ports. Both switch and bridge looks the same. But internal architecture is not same. You see, both have got software. This is also running an operating system. This is also running an operating system. Then why? Bridges are called as software-based device and switches are called as hardware-based device. Both have got software, both have got hardware, both have got hardware. You see, physical box, physical port, physical box, physical port. But we don't call bridge as a hardware-based device. We don't call switch as a software-based device. Though there is a software on both. The operating system is software. Fine. Then what is the difference? You see, the watch. If you see the watch today, and the olden days watch, like 30 years before watch, both shows the time. Both have got needle, the small needle, the large needle, and also as thin needle. Both have got the 3 clock hands. But the olden days watches are hardware based device. The current day watches are very light, not too many hardware parts in it, but look wise both same. But the olden day watch is too heavy because it has got a lot of hardwares in it. Whereas today watch, if you open, you will see one thin motherboard and very tiny motor and a battery. Nothing more. Software. So those 3 handles, the 3 needles that shows the time are driven by the software here. Only software in control. The whole job of showing clock and the date is taken care by software in today's watch. Whereas in the olden days watch, it was full mechanical. All those 3 needles were being controlled by pulleys. Pulleys, small, tiny pulleys inside, and a tensioned spring inside. That makes the clock run. Likewise. The job of a switch. So here, if you see, it's the opposite. One operating system with the motherboard and CPU, all operations of a switch, all layer 2 operations are carried out by a single CPU controlled by operating system. Whereas in switches, you got plenty of hardware, not just CPU and operating system and motherboard. You got many sub CPUs, small CPUs called ASIC chip. This this hardware is not present in bridge. Because you don't have the chip, the function, the job of this chip also need to be carried out by the same CPU with the help of this single operating system. So it is that operating system in charge of all jobs, whereas some layer 2 functions are carried out by ASIC, the other functions are carried out by CPU. Here the load has been shared. You see, when there is only one driver, let's say I go for a family trip, and if I the only one who have to drive, I cannot go long distance. After some time, I'll get tired. So the distance covered will be less. Instead, if my partner also drives, then when I am tired, she will drive, and then the distance covered will be more. Likewise, when you have only one CPU to take care of all the job, the amount of traffic this switch can handle comparatively less than this device switch. Switches have got many mini CPUs called ASIC chips. ASIC. This chip is depending on how costly the switch number of chip. Let's say you have 24 port. If you pay more, then each port will have one chip. Then there will be 24 ASIC chip. Application specific integrated circuit. There will be 24 small CPUs along with one big CPU. Depending on the price again. So more ASIC, more traffic this switch can handle. So depending on the size of your organization network, you will decide how big, how many ASIC chip need to be in your switch. See, appearance wise, both look same, but this has got no ASIC at all. So there is only one CPU to do all the job. So there will be some limitation. It cannot handle more. Whereas here, robust. It can handle more amount of traffic. Switches have got more ASIC, application specific integrated circuit. This ASIC hardware is not in bridge. That's why bridge is purely a software based device. That OS, the operating system, have to do all the job of ASIC. Right, so this is the difference between the bridge and a switch. Now there is also another device, not many people use it today, called hub. Hub is also like a switch, but in a small size. The number of ports in hub will be somewhere between 2 to 8, not more than 8 ports. The reason is hub cannot handle more than that. That's why you don't see that in now in enterprises. Just 2 to 8 ports, maximum 8 ports. This hub will come again later. Switches will also come again later. Now the reason why I took hub is there is also another device which is totally gone from the scene, but why we are learning then to answer questions in interview sometime they may ask, called repeater. Now, when you talk about repeater, what is the difference between repeater and the hub? Both job is to regenerate weaker signal. You see, when there is a computer very far away, the signal strength will get weaker and then it will diminish. So when you keep a repeater, the signal can be regenerated. That's why you need a repeater. It regenerates the weak signal so that the signal can be carried to long distance. Now, what is the difference between repeater and the hub? Hub is a multi-port repeater. You see, this repeater will have only 2 ports. Just 2 devices you can connect. Third device, where will you connect? No ports. You need to buy hub. This is a multi-port repeater. You can have up to 8 ports. But again, hub cannot have more than 8. That's why we need what? A bridge. But bridge is a software-based device that can also only support up to 25 device, 25 ports, not more than that. Whereas the switches can be from 12 to even 300 ports. That is why we go with switch. You see, so sometimes people may ask you this question: what is the difference between hub and a repeater? A repeater has got only 2 ports. Hub is a multi-port repeater. Similarity is both regenerate signal. And then sometimes they may ask, what is the difference between bridge and a switch? Bridge is a software-based device because there is no ASIC chip on it. All operations are carried out through the operating system using that single CPU, whereas the switches have got more ASIC, so the load has been shared between many CPUs here. ASIC is also a CPU. Apart from that main CPU, you got more CPUs. As a result, switches can handle large volume of traffic. It can support more number of ports. Switches can help to communicate more faster than bridge. Because of the additional CPUs called ASIC, you call it as hardware-based device. And I told about router. Router is to connect multiple networks. Each department will be in different network. What does that mean? Say for example, if you have a sales department in 10.0.0.1, 10.0.0.2, and if you will have a production department in 20.0.0.1, 20.0.0.2, they cannot, even if you connect a wire, this A cannot talk to C, B cannot talk to D. C and D can talk because they belong to same network. A and B can talk because they belong to 10 network, same network. If you want to communicate between this 10 network and 20 network, you need a router. Only with the help of router, communication between different network is possible. And then we spoke about firewall. Firewall is also a routing device, switching device inbuilt in it, but they got additional capability. What is that? They can protect our network from anomalies. They can protect our network from abnormal packets, intruders, rogue traffic, mitigate the attacks. In order to mitigate the attacks, we keep firewall in the borders. See, firewalls can also do routing job. Can we replace all the routers with firewall? No, because they are very costly. Compared to router, firewalls are very costly. You cannot keep all the routers, not necessary. Just keep in the border. The border where the internet connects to your office network. That is where we keep the firewall. This firewall will inspect every single packet coming in and going out. And if only the policy allows to permit the traffic, it will permit. If not, it will deny. That is how it prevents the attack. And this firewall is not in the course, as I said. This is for our knowledge. Why do we need firewall? In order to prevent intruders, abnormal packets, attackers entering into our network. And the host, the word host is given to the end device, our laptop, printer, iPad, cell phone, all these end device, the end users. They may be non-technical people, but they are generating traffic. Those devices that generates traffic, those devices that receives traffic, they're all called as host. Even a printer receives the traffic from the network and prints the papers. So that is also a host. So when I use the word host, sometimes it may refer to a printer also, but most of the time it refers to a laptop or a PC. Host means computer most of the time. Right. Do you have any question on what we have covered today? We just covered network basic. Hmm. Hmm. Correct. So the question is, why only a router can help communicate between two different networks? Why not a switch? You see, a switch is designed to only move the packet using the MAC address, whereas routers are designed to move the packet using IP address. IP address, you see, 10 is one network, 20 is another network. This is IP address. To understand this address, you need a router. Only a router can understand these addresses. Whereas switches understands another address, which is called MAC address. This MAC address is 48-bit size. We'll talk about MAC address later. These are all inbuilt address, burnt-in address. You don't know really your MAC address, but you will know your IP address. Because IP address is what we use to communicate, but MAC address is what behind the screen moving the packet. So what I'm trying to say here is in short, to route the traffic between two different networks, you need a device which can understand this different network, 10, 20. Switches don't understand these addresses. They understand only MAC address. So they will only move the packet if the devices are in same network. Between these two devices, because they are in same network, just the MAC address only will know this packet belongs to this computer. Only a switch can move the packet according to the MAC address. The communication between the same network device or using MAC address, and switches can do that. Whereas communication between devices in two different network, because then two different network is involved, the networks can be understood only by routers. Anyway, this entire course is about this. You will be learning more in depth of what I said now in coming classes. Now, any other question? Hmm, that's nice. Correct. Switches and routers, they totally have two different physical hardware architecture as well as the software architecture. They're totally two different uh, uh, layer device. Hardware, software, both are totally different from one another. Switcher software are different, router softwares are different. Likewise, even the hardware design is also different. In the routers, you will not have too many ports. In the switches, you will have too many ports. Because switches are to communicate between the networks within the office. Inside office, you will have 300 computers. Whereas networks will not be 300. If you have 10 departments, you will have only 10 networks. So you don't need too many ports on the routers, whereas on the switches, you need too many ports. So physical look wise, they're not same. Inside hardware, they're not same. Software is also not same. Any other question? All right.